Now we'll see in more detail about what is MESFET and how it is going to be operating when it is made up of gallium arsenide. So MESFET is a modified form of MOSFET in which gallium arsenide epitaxial layer was grown on semi-insulating gallium arsenide substrate. So in MESFET you have only metal semiconductor junction, whereas in MOSFET you have three layers: metal. You have a metallic layer. Below that you have an oxide layer. Below that you have semiconductor layer. Okay, so that is the major difference. So MESFET is a two-layer device, whereas MOSFET is a three-layer device. And I'm going to use gallium arsenide as the material for using for fabricating MESFET because I am focusing on high frequency operation of my device. Okay, so the operation is very similar to JFET only. So the use of gallium arsenide has more advantages. One is electron mobility is 5 times larger, so which makes the device very fast, or it enables the high frequency operation of your MESFET. While the peak electron velocity is about 2 times of silicon. So the velocity is 2 times larger than silicon. The mobility is 5 times larger. Put together 10 times, you have a better effort compared to silicon. That is the reason why you prefer MESFET made up of gallium arsenide than silicon. Second thing, it is possible to fabricate semi-insulating gallium arsenide substrate, which eliminates the problem of absorbing microwave power. So when you are going to operate at a very high frequency, the microwave power will also be very high, right? So such high power, if it is going to be absorbed by your device, the device becomes very hot, and the heat had to be dissipated from the device as quickly as possible. So if you are going to have a semi-insulating substrate, then the heat absorbed will be less. So your device will be having a better stability, and high frequency operation or high temperature operation of the device is possible when you're going to have a semi-insulating gallium arsenide substrate. So, to significantly two advantages, what we are seeing here is electron mobility is 5 times larger than silicon, and the electron velocity is 2 times larger. And second one, the problem of microwave power being absorbed at high temperature or at high frequency is completely eliminated because I am going to use a semi-insulating gallium arsenide substrate. I cannot use a fully insulating gallium arsenide. Then the purpose of semiconductor itself is going to be lost, right? So I'm going to use a semi-insulating gallium arsenide substrate, which is going to give an added advantage that at high temperature operation, the microwave power will not be absorbed by my device. Okay, so thereby your device will be more and more stable at high temperature operation. So the MESFET has certain processing and performance advantages that as the low temperature formation of metal semiconductor barrier in comparison with the PN junction made by the diffusion or grown processes, low resistance and low voltage drop across the channel width, and good heat dissipation for power devices. So these are the advantages your MESFET is giving to you. So the resistance is going to be less, so current flow can be high. So when current flow is high, it is going to act like a high power device, and also low voltage drop across the channel width. So as you measure the voltage drop across the channel width from source to drain, it is going to be very low. So and it can be a good heat dissipation for power devices because I'm going to have a semi-insulating gallium arsenide substrate. Because of that, it can act like a good heat dissipation for power